This PDP-1144 is really shaping up to be something special, and actually I think my favorite thing about this machine is that it gives me the opportunity to explore things that no hobbyist ever would have been able to afford in 1980 when this thing released. If you look at the card cage, you can see it's already stacked. This card over here is the terminal interface and TU-58 interface. These two make up the commercial instruction set. These are incredibly rare. The next 6 cards are the CPU with the floating point option and the cache option. And then these 4 cards here make up 4 megabytes of memory. On a computer from 1980, that is an insane amount. And then finally over here, we have our Emulex SMD controller card that goes to a Fujitsu SMD drive down below. This is already an absolutely insane setup, and if this was as far as we were to ever take this machine, that's nothing to be ashamed about. This is a brilliant PDP-11 that's pretty well stacked, and it all works. We can boot into RSX-11M, and that Fujitsu SMD drive splits up into 2 RK07s and an RK06 within the operating system, so we have a ton of storage space, a really fast CPU, a boatload of memory. This is a wild PDP-11, but I'm looking at the backplane and it's only half populated, and this is obviously not as far as we're ever going to take this machine. The biggest thing that I want to add to this is a vector processor, so that's going to be either an FPS 100 or an FPS 3000. We're kind of exploring both avenues, and I'm not really sure which one we're going to end up with. Most likely we'll choose the one that results in me losing the least amount of hair, because vector processing is hard, yo. But aside from the FPS journey on the PDP-11 here, I'm really struggling with a question that doesn't just apply to it, but applies to everything in this room, which is, what do you do with it? Like, once you restore a vintage computer and it's fully functional, then what? Like, this is a really tough question, and I mean, I don't want to go, like, this is like a full-on hour diatribe about trying to figure out what is applied vintage computing. But for this PDP-1144, I think I've figured it out. I think I figured out the application that makes me really excited, so to the point where I'll sit down and actually use this thing on a regular basis. And that is that I think it would be absolutely amazing to slip an ADC into the Unibus, an analog to digital converter, and get the PDP-1144 hooked up to the Auger Electron Spectroscope, so that whenever we're analyzing the surface material of something like, say, a hard drive platter, the spectrum that thing spits out can go into the PDP-11, turns it into a nice digital spreadsheet that we can then manipulate and change in whichever way, and then we can display the spectrum and print it out or plot it out. This, I think, is going to be really amazing. But the real party piece to that would be if I could take that spectrum file and send it to my modern desktop so that I can then upload it to Wikipedia or share it with people, or like, that would be absolutely amazing. But in order to do that, we have to get the PDP-1144 onto my local home network. And that seems really wild for 1980, but it turns out that's actually doable with this card right here. This is an M7521 DELUA, D-E-L-U-A, network interface card for a Unibus system, which means it's going to work perfectly with our PDP-1144. And my life has apparently been filled with the 68K lately, because this has a full MC68000 CPU on it. It also has a collection of DRAM and some ROMs. So ROM, RAM, and a CPU. This is effectively a single board computer that has one purpose in life, and that is to do networking shenanigans for a PDP. But this is actually an evolution of an earlier network card called a DEUNA, D-E-U-N-A, and I actually have one of those as well. It's a 2-board set, and this is an M7792 and M7793. And so the 68K takes all of this and shrinks it down to essentially a single board. Saves some space on the backplane, saves a little bit of power, but this DEUNA is our backup. If the DELUA here does not want to work because, you know, maybe something's broken on it or whatnot, I really don't want to sit down and try and troubleshoot something that I don't have the schematic for today. So if this doesn't work, we're going to fall back onto the DEUNA. But we're going to start with trying to get the DELUA to work, and honestly, I think it'll probably be fine. Deck stuff is often built like an absolute tank. Now we need a bit more than just the card itself, because you'll notice that there's no like like RJ45 or Ethernet port on here that I can just plug into my router over there. All we've got is this little ribbon cable connector up at the top here. And if I understand this correctly, you have a cable that goes from this to a bulkhead connector, which looks like this. And this is more than just a DD15, I think that's right, DD15 on the front. There's a DD15 on the back, as well as a circuit board with some extra stuff on it. Looks like a couple of capacitors, a big transistor, and maybe a couple of diodes. But where do you go from there? And looking through the documentation, looks like it would originally go to something like a vampire tap. First of all, great name, but also I don't have one of those. Looks like another option is one of these right here. I think this is essentially a smaller version of that vampire tap. But again, like, I don't have anything to plug this into, so we'll ignore that for now. And then you have the solution like one of these little guys right here, which you have your 15-pin connector there and then a proper RJ45 on the back. So that's everything we need to get this going, except for the cable that connects the card to the bulkhead. I don't have that. I do have a cable that is close though. This cable right here has the correct connector on this end, has the plug in the right place, the correct number of pins, and it has a 15-pin connector on this end, but you'll notice that it says DELQA above it, D-E-L-Q-A. That is the Q-bus network interface card for things like PDP 1173 or VAX, some of the early VAXs. It's a different bus, but this might work. I imagine that the 15-pin connector here hasn't changed, and we don't have a bulkhead, but that bulkhead may not be necessary if we're using one of these small adapters here to go to like an RJ45. So we might be able to just plug that in and go on this side. But what I don't know is if the pinout of this connector that plugs into the card has changed. And the downside is that while I can find a pinout for the DELQA, I can't find a pinout for the DELUA, so I don't even know how to confirm if this cable will work or how to make a new cable if this one won't. But we'll burn that bridge when we get to it. First things first, let's make sure that we still have a working system. So I've got my Rainbow 100 powered up here. This is going to act as our data terminal. So I just need to hit T to enter terminal mode, and we got a little blinking cursor up top there. I just need to flip the main switch on the front of the machine, and console version 3.40C, halted at 165.714. That is business as usual. Let's see if it'll boot from that hard drive, which is going to be a B, I always forget what this is, DM maybe? Yeah, I think that was right. We'll see what it says here in a second. Such a long wait. There we go, RSX11M Plus. So the last time that I did a video on the machine, I had RSX11M on it. We've since upgraded to M Plus, specifically so we could get this whole networking thing going on here. So it's gonna ask me for the date and time. I'm just gonna hit enter to skip through that. And here's where this is why we put M Plus on it. You can see it says start DECnet. We're not going to do that because I don't have the network card in there, so I'm going to hit no. Start TCP IP, again, I got to do no on here. But the important thing is that the operating system has been set up for that card already. And then we set it up with a bunch of useful things that'll make the operating system a lot more usable. There we go, we're fully booted up. I mean, you can see it says Saturn install finished. This has nothing to do with the actual RSX11 itself. This is an additional program that Mark's been working on that I'm like super excited about because it lines up really well with what we want to do with the Auger. But we're gonna get into that in a future episode. Let's double check that everything looks healthy. So I'll do a show dev here and I'm gonna have to hit hold screen to stop it. So yeah, there's all of our drives. We have DM0, DM1, DM2, which is going to be two RK07s and an RK06. That's how that Fujitsu drive presents to the machine here. Everything is working perfectly. All of our hard drives, everything's mounted correctly. Like, this is excellent. So let's plug the DELUA in and see, hopefully we don't break anything. In order to do that, we got to do we got to shut the whole thing down. So we got to do a run $ shut up. And like, I'm not making that up. That is legitimately the name of the command to power off RSX11. So we're gonna do 0 minutes, no reason. Okay to shut down, yes. Gave me a couple of beeps there. Then it's going to go through and dismount all of our drives, starting with DM0, then DM1, DM2. Once all three of those are dismounted, it's going to fully close down the operating system and we'll be okay to turn the machine off and slot that card in. So the next big question is, which slot do we put it in? All slots should be equal, except that it needs to go into a slot that has the NPG jumper not wire wrapped on the bottom. But I've gone through and checked, and all of the slots on this secondary backplane don't have the NPG jumper wire wrapped on the bottom. So we should be able to put it anywhere. I'm going to put it in this second to last slot right here that I currently have a Grant continuity card in. And that's because the cable that we're hoping to use with this thing is a little short and awkward. Hopefully by putting it in the last slot here, I can route it a little easier back over here somewhere so that it's not getting in the way of everything. Now I just need to take my big ribbon cables from my hard drive here and pop them in, and then we'll be good to go for a test. Now I'm supposed to have this thing hooked up to a network or a loopback connector, and I don't, so I'm fully expecting this thing to throw an error, but these 8 LEDs here should tell us something. Also, I just want to see if it goes up in smoke. Hopefully it doesn't. So we'll bring the power up. Okay, so that immediately threw an error. I think it's supposed to do a bit of a cycle pattern as it does the self-test, but that's the error it threw, which is 1000010. And looking at the documentation, 1000010 is a RAM checkerboard test. So maybe that means that we have some bad DRAM on the board. Maybe we have to have it plugged into a network before it actually does all this self-testing stuff. I don't actually know. Now, I've spent a lot of time with the multimeter on this bulkhead and with this Ethernet adapter here, as well as the cable itself, and I think we're okay. I think we're in the clear to just kind of plug everything together. I compared the cable to pictures of Mark's cable, who has the official cable for the bulkhead, and all of the communication stuff is in the correct place and just goes straight through. So that's not an issue. The only issue is how power is run, and it's all in the same pins. I'm just not fully understanding how it works. It's confused. I think we're just gonna plug it in and see if we get smoke out of something here. At the very least, we're hoping to see the power LED come on here, and hopefully we don't hear any bad noises out of this thing. So we'll go ahead and flip the power switch on. Yeah, we got power and polarity. We don't have SQE test and link. That's to be expected. We're not plugged into anything. So let's run a cable. Oh, I don't think that's going to be long enough. Oh no. All right, we'll see. Maybe I can stretch it. All right, the cable is about 6 feet too short. I'm gonna have to make a new cable, but I think I've got it for now. Check this out. It's not ideal, but stretches all the way over towards the NCR where it plugs into the router back there. We're gonna test it with this and see how it goes. All right, we'll flip the power switch on. We got a link. That's good. But my diagnostic LEDs are still stuck on that RAM checkerboard pattern thing. So yeah, I think our DELUA has bad RAM on it. That's not ideal. In my completely unprofessional opinion, I think it's one of these 4164 DRAM chips here. Usually 4164s are pretty good, but they have been known to fail. Unfortunately, this is not a computer. It looks like a single board computer, but it's not actually a single board computer. And so I don't think there's any way to like run diagnostics to narrow down which one of these chips has gone bad. If it's only one, it might be multiple. Man, I really don't want to just like willy-nilly go at it, and I'm sure that if I try to figure it out which one it is, I'm gonna lose like 3 days doing a diagnostic on this. So we need to go to our backup, which is our DENUA dual board set here. It looks dramatically more complex, but actually it looks to be in cleaner shape, so I think this one was taken better care of than the DELUA. All of the heavy hitters are still here. We have the exact same connector here to go to our Ethernet cable. We have our 7 LEDs across the top here for our status. And then we have 2 big dip switches to set the vector and the address. So I just need to double check those, look up what the 7 LEDs are supposed to mean, and then I gotta find 2 cables that are shorty ribbon cables that connect the 2 boards to each other over the top. That's gonna be a little bit of a pain, but I think I might have something if I go digging through my ribbon cable box. Time to go mobile. That's my best Bane impression. If you don't have a random box full of ribbon cables, what are you even doing? Check this out. This big guy has a bunch of ribbon cables in it. It's full to the brim. So the cables that we need are somewhere in there. This is gonna take a while. These are my guys here. I think these are actually the ones that are supposed to be with this, or at least they match the ribbon cables that are on the picture on Gunkies. So, I don't know, bodes well. I've changed bulkheads to one for a DECNA instead of the DELCA. It's still a Q-bus thing, but this one's got fewer wires on it, and those seem to match up better with the wires that are on Marks. So hopefully we'll have a little bit better luck with this. But again, that wasn't the problem with the DELUA. I think it's got a bad RAM. This one has some LEDs on it though. Let's see if it at least powers up. They're doing a lot of stuff there. Okay, I think that's where it's ended at. This one on the far edge is a cable LED. I think that's supposed to be on all the time. These though, I'm gonna have to look up. Okay, the current state is 2 is off, 3 and 4 are on, and then the rest are off, which says PCSR1 lower byte and T11 DMA read. That's an M7792/Unibus thing. So this may be what it's doing since we're currently at ODT, so maybe we need to actually boot into RSX11 to see what happens. It's a little precarious. I can't actually sit at the computer because I got this Ethernet cable in the way, but I've got the camera at least pointed at the monitor, so you guys should be able to see what's going on. I'm just gonna lean over here and I'm gonna type B space DM, hit return on that, and it should start booting into RSX11. I'm keeping an eye on the LEDs. Yeah, the LEDs changed. They're cycling through now. They're all on. I don't know if that's a good or bad thing. We'll do, just enter on the date and time. We will start DECnet, so I'm gonna do a yes. We'll start TCP IP, yes, and I don't have a crash explanation. So we're just gonna let it sit here and boot and see what it does. We seem to have hung at NCP set sys here. I have no idea what that is. Maybe that's a network thing. I'll hang out for a little longer and see what it says to me, but I don't know. This is gonna require some troubleshooting. Maybe it might turn out that both of my network cards are unhealthy, and that would suck. It did eventually get past that, but I don't think things are quite right. Like this, it's going so fast. Dang it. Okay, I think this is like Ethernet stuff that's trying to start here, and it's not starting. So it is pushing through the boot process here. Now it's mounting all of my hard drives, and now it's installing the Saturn software that we're going to get into in a future episode, and we're fully booted up now. Oh, maybe we aren't fully booted up. This is new. Event type 5.13 initialization failure. Apparently it's March 30th, 1982. No Ethernet found for IF0. DHCP, some errors occurred. Will renew leases in 60 seconds. So it's very much so trying to start TCP/IP here, and it's not working. So when in doubt, XXDP time. XXDP is a set of diagnostics written by DEC to test pretty much every official DEC card out there. And since the DEUNA is an official DEC card, we have specific diagnostics for it. But we need to load XXDP up. It's essentially an operating system unto itself. And I don't have that stored on my hard drive. So I've got a Unibone in there that has a disk image full of all of the XXDP diagnostics. So I'll just hit an LS here, see if I can remember what that one is. It's this one on the bottom here, XXDP DL0. So we just do like a ./XXDP underscore, and then I can tab through the rest, I think. And then we'll just go ahead and hit enter on that, and it should start emulating this RL drive. And yeah, there we go. We can see it spinning up the virtual RL drive. That's pretty cool. So yeah, it's creating virtual RL drives, and these hold all of the XXDP diagnostics, but we should be there. I can check on the 1144 itself by doing an E10000. This is going to examine the memory in that location, which is 12700. That is the correct instruction for the bootloader. So we just do its S10000 now, and yeah, there we go. XXDP plus DL monitor. I don't particularly care about the date. Now we want to run the specific DENUA test, which is ZUAAA0. So I'm going to do an R space ZUAAA0.bin. Yeah, there we go. DENUA repair diagnostic. Using it is DENUA, and then it gives me a restart address if I need to restart this. So we're sitting at the prompt of this particular repair diagnostic. I need to start running it, so I'm just going to do an STA for start. It's going to say change hardware. I think I want to say yes to this. The number of units I have is just one. And then the PCSR 0 address is, I think, 174510. We're going to go ahead and hit return on that. And then the vector address, I believe, is 120. We're going to hit return on that, and it should start running the tests. And already we've got interesting errors. PCSR 1 bit 15 is not clear. So yeah. Register access test failed, reset test failed, self-test failed. We are off to a great start here. It looks like all of this is the exact same failure. So the DNI bit is not set. So we need to figure out what the DNI bit is, but I'm afraid this is going to be a very deep failure on the DENUA, which is going to be very hard to troubleshoot. All right, it's been a couple of hours since I last had the camera on, and I've kind of run down some meandering paths here. I'll try to weave this in a way that makes sense. I decided to go back to the DELUA because the idea of hunting down a bad RAM chip seems way more attainable than hunting down whatever's bad on the DENUA, at least for right now. And so I threw the DELUA back into the backplane, fired up, got into XXDP, but I don't have the DELUA-specific XXDP test. So I figured I'd just try and run the DENUA test anyways and see what it does. So I've got the DENUA test pulled up here. I'm going to hit ST for start. I'm going to hit STA for start. There we go. Change hardware, yes. Units, 1. This is going to be a 174510, I believe. And then the vector is 120. And yeah, there it goes. All right, so right off the bat, we get some register access tests that fail, but this is the next tests are what jumped out at me here. This is fascinating because we're doing register read-write tests here on PCSR2 or whatever. And you can see, look at this. It says data written 052524, data read 052525. Same here, 31462, 31463, 7416, 7417, 376, 377. It looks like our least significant bit is stuck on 1. Like, every time we should get a 6, we get a 7, which would be, you know, 110 versus 111. So we just got to figure out which IC is the least significant bit. This is the RAM of the DELUA, and they're just 4164s, which are 64K by 1 bit. So we need 16 of those to create a full 16-bit word. And because they're 64K, that means that we have 64 kilowords. But you'll notice that there's more than 16. We actually have 18 chips here, 2 rows of 9. And that's because 2 of them are dedicated to parity, essentially error checking the RAM to make sure that everything is coming back copacetic. And so I just need to figure out which one of these chips equates to the least significant bit. And I took a guess that it was this one on the bottom here, but that one was clearly not the case because we're still getting errors. And the problem is that I got excited. I should have buzzed it out and figured out which one actually was the least significant bit. So D0 on the 68K here is pin 5. So there's 1, 2, 3, 4, 5. That one right there. And if I come down to this chip here, yeah, can you hear it beeping? Yeah, so I missed it by 1. This IC, I think, is the least significant bit. These 2 are going to be parity. So I need to pull that one, socketed it, and put in a new a new IC, and hopefully that fixes our problem. I mean, there could be plenty other wrong. I could also be way off. D15 could be the least significant bit. I don't know. Hopefully this does it though. I'm gonna try replacing that one. Moment of truth, will it pass the RAM checkerboard test, or did I replace the wrong chip? We're looking at these LEDs right down here, so we'll flip the power on. Nope. Dang it. Exact same spot. Oh, nerds. All right, let's try this again. This time I replaced this IC up here. This is D15. Maybe I got the bit order wrong, where like D0 is most significant and D15 is least significant. I don't know. We'll give this a shot. If it doesn't work, then I'm kind of out of ideas. All right, we're still looking at these same LEDs here. We just want to see it get further along in the process. So power coming up. Nope. Nope. Oh, man. Well, we had a big swing and a miss today. I ran the same XXDP, and it's still throwing back the exact same values that we saw before I changed any RAM chips. So either I didn't actually find where the least significant bit is, or the register that it's hitting is not in that DRAM. It might be on like a different specific register chip somewhere else that's bad. But without schematics or at least a nice technical manual on the DELUA, it's going to be really hard to figure that out. I don't know, man, I really wanted to like FTP some files over today, and it just didn't happen. So I don't know. I'm not going to give up. This is something that I really want to have happen. So I'm gonna stop here, formulate a good game plan about how to troubleshoot either of these cards, and then when we come back to it, we'll come back with renewed verve, and hopefully we'll emerge successful. Oh man, sometimes you're the windshield, sometimes you're the bug. I want to thank you all so much for hanging out with me today, and I hope to see you in the next one.